Good afternoon, everyone, and welcome to this session on building scalable custom authorizations for your applications. My name is Kunal Pansari. I'm a solution architect at Amazon Web Services. And with me on stage is Con, Chief Technology Officer of Grosvenor Engineering Group. Welcome, Con. I'm sure you've built custom application and you're looking to build authorizations for your application. In this session, we are going to talk to you about how you can build scalable custom authorization for your applications using Amazon verified permissions. Let's see how we have organized this session for you. We'll start with establishing why there is a need for authorization as a service. We'll look into verified permission and its features. I like learning things when they're in action. So I'll build a small demo for you how you can leverage verified permissions. And then I'll invite Con to showcase how Grosvenor Engineering Group have leveraged verified permission to simplify permission management and authorization in their applications. Finally, I'll recap and share some of the resources that will help you get started with verified permission. But let's start with something basic, something you already know, authentication versus authorization. Authentication is about verifying user's identity, establishing who the user is. And authorization is about what a user with valid identity is allowed to do in our applications. As an example, if you create a user in AWS Identity and Access Management Service, the user is authenticated when they log in. But can they create another user? Well, it depends on the role that you have assigned to the user, which defines what they are authorized to do. The focus for today's session would be exclusively on authorization. So let's start with how authorization is typically implemented in applications. Here I have a sample finance application, and as you can see, authorization logic is written within the code. So what are some of the challenges with this style of implementation? To understand these authorization rules, you need to understand code. If you have any changes to authorization rules within the application, you need to recompile and redeploy the code. And from security point of view, auditing is challenging. Now, another style of implementation is, of course, databases. You need to define a database schema. You need to decide what groups, members, and attributes you're going to support. You may also have to consider if you're going to support wildcards and regular expressions. And of course, you need to be able to calculate precedence. If one row in database says allow user and other row says deny, how do you decide which takes precedence? And to support all this, you have to have a custom UI. So this all may be time-consuming, may not scale, difficult to do right, and may lack governance. And before you know it, you have built an entire application just to support authorization. So how do we improve on this? How do we define a better way of managing permissions? And the answer is policy-based authorization. This is not a new concept. With policy-based authorization, you define authorization as a set of actions that a verified principal can take on resources within your application. And if you're familiar with IAM, which is Identity and Access Management Service, it does exactly the same for your AWS resources. You create IAM policies, and IAM as a service acts as an evaluator of that policy, and it lets you access your AWS resources. But IAM was not designed for your application. It doesn't have any knowledge about your application authorization rules. So how can we take similar approach for our applications? Amazon verified permission is exactly what we have discussed. It is authorization as a service. With verified permission, you create granular permissions for your application using AWS Management Console, APIs, or command line interfaces. With verified permission, you create your authorization rules for your application as policies, and you store those policies independent of your code. You test those policies independent of your code. So no more redeployment of your code is required when there is a change in authorization rule. Verified permissions contains schema definition, policy statement grammar, and automated reasoning, which scales across millions of permissions. And this enables you to enforce principles of default deny and of least privilege. And these all features facilitate the deployment of fine-grained, in-depth authorization models to meet your zero trust objectives. At the core of Verified Principal is CDAR. It's an open source project from AWS. It's a domain-specific language explicitly for authorization and policy evaluation engine. CDAR is simple yet expressive language, purpose-built for common authorization use cases such as role-based access control, commonly known as RBAC, and attribute-based access control, which is ABAC. Any CDAR policy has two sections, a head and a condition. Every CDAR policy would have four key elements: principle, action, resource, and context. You can look at the structure of a policy and tell at a glance if the policy supports RBAC, ABAC, or a combination of both. All right, this was just an overview of what verified permission is and how CDAR works. Let's look into our demo. Onyx has not been feeling well, and it's time to visit a veterinary clinic. But before we do so, let me introduce you to a few people. Dave is the owner of Onyx. Sally is a clinic administrator who's responsible for booking appointments for clients. Dr. Jane is the primary doctor for Onyx. And Dr. Adam is a specialist who needs to perform scans on Onyx. They all use veterinary clinic portal. And within this portal, as you can relate it to any application, I have three main operations: viewing client records, booking appointments, and referring to specialists. Through the demo, we'll see how these personas interact with the portal to have and define their access requirements. Once we define their access requirements, we'll see how these access requirements can be translated as policies on verified permission and how these policies are evaluated. So let's start with first use case. The use case here says viewing client records and scheduling appointments. Let's look at the demo of the portal. Here's the portal, and if I were to log in as Dave, who's the client here, I should be able to view my records because, of course, I'm a client here. I should not be able to book an appointment for myself because that's the job of an office administrator or clinic administrator, so this action should be denied. And of course, I should not be able to refer myself to a specialist because that's a job of a primary doctor. So how these authorization rules are defined and converted into policies? Here, the first rule says, deny all action across clinics. And this is a safe check in my system to prohibit a principal accessing resource in a different clinic. And this can be translated into a policy stating that when the principal's clinic ID is not same as resource's clinic ID, do not allow access. The second authorization rule here says, allow clients to view their client records. And this can be converted into a policy, a permit policy, to allow principal who belongs to a user group client to take an action, which is get client records on resources which also belongs to client groups. Of course, the principal and the resource has to match. Now let's take a look at access requirements for Sally. If I log in as Sally, being an office administrator, I should be able to view all the clients that are registered with this clinic. I should be able to view their records. I should not be able to refer them to a specialist because, again, I'm not a primary doctor. But I should be able to book an appointment with their primary doctor. In this case, I'm going to book an appointment for Dave or Onyx with Dr. Jane, who's the primary doctor. So let's look at how these authorization rules are converted into policy. Here, the first rule says, allow admins to view client records and schedule appointments. And the respective policy is, the principal, which belongs to office admins group, is allowed to take an action, get clients' records, and book appointment for the resources which belongs to all clients group. And this is an example of role-based access control, purely because the permission is granted based on user's role, which is office admin in this case. The second authorization rule here is allow primary doctors to view client records of their clients and refer them to specialists. And this is translated into policies as the principal has to belong to a group called all doctors. And they are allowed to take action getting client records and referring them to a specialist for the resources which belongs to all clients. So in this case, the client Dave has to belong to all clients group. But with a specific condition that resource is primary doctor. Resource in this case is Dave. Dave's primary doctor has to be the principal who's logging in this case, Dr. Jane. Now, as you have noticed, I'm creating few policies. From verified permission perspective, you want to group all these policies for your application in a logical group, which is called policy store. And I'll talk about policy store later. The second use case here is referring to Onyx to a specialist. Again, taking a look at the demo here, I'll start with logging as Dr. Adam, who's the specialist. At this point in time, Dr. Adam doesn't have any relationship with Dave. So he cannot view client records. They should not be able to schedule an appointment. And of course, referring is not allowed because they themselves are specialists. But if I were to log in as Dr. Jane, who's the primary doctor, I want to view records of the client because I have direct relationship with that client. And I should be able to refer the client to a specialist. In this case, I'll create a referral for Dr. Adam for the period of 3 months, and the referral is for X-ray. Now, if I were to log out and log back in as Dr. Adam, I should be able to view client record. So what happened behind the scene? The application, the veterinary clinic application, created a dynamic policy, and this was a time-bound dynamic policy because the referral period was specified as 3 months. And the authorization rule says, allow specialists to view client records during referral period only. And the policy that was created behind the scene was permitting principal that belongs to specialist user group to take an action which is getting client's record on resources that belongs to all clients group with very specific condition. The principal has to be Dr. Adam. The resource has to be Dave. And the context has to be query time, in this case, less than 3 months. This is an example of time-bound dynamic policy that your applications can create for use cases such as delegation, elevated access, and sharing data between resources. Now let's take a look at the application architecture. You've seen the policies. You've created the policies. You've stored the policies as policy store. How does it all hang together? Here, I have veterinary clinic portal on left-hand side. I have backend APIs for this veterinary clinic application on far right-hand side. In the center, I have API gateway, which acts as an access point for the backend APIs. At the top, I have Amazon Cognito, which acts as my identity provider. And as you saw in the demo, everything starts with users authenticating themselves. In the bottom, I've got verified permission, which acts as my authorization engine. The flow starts with user authenticating themselves. Now, it's a common use case that for public clients, you may want username password, but for your employees, you may want them to use employee credentials, and you can easily federate. Once the user is authenticated, a token is issued to the application. This token contains user information, profile attributes, group information. You could additionally enrich this token with additional attributes, which will help you for your authorization flows subsequently. From this point in time, any flow that goes to API Gateway carries the token as header. API Gateway leverages a Lambda authorizer, which performs 4 key actions. It verifies the token, extracts the principal from the token. It formats an authorization query for verified permission. It calls isAuthorized endpoint for verified permission. And based on the response from verified principal, it enforces the decision. If the decision is allow, the call is routed to backend API. Otherwise, an unauthorized error returned back to the front end. Now, this is a sample serverless architecture. You can, of course, replace API Gateway with AppSync or APIs running on containers, as long as you integrate a verified permission call within your APIs. Now, let's take a closer look at the Lambda function, which is where the integration with verified permission happens. In this Lambda authorizer code, I want to answer a question. Can a principal perform a certain action on a resource with a specific context? And in my use case, I want to answer the question that, can Dr. Jane create a referral for client Dave for a context which is 3 months? And to do this, I have a sample Python code. Within this Python code, I have 4 important steps. The first step is to verify the token that has been returned by Cognito to API Gateway. The second step is to format a query for verified permission. And this query contains 6 important pieces of information. The first piece is the policy store identifier. And this is the policy store that I was talking to you earlier about. You create policies and store them into a policy store. The second piece of information is the principal who's trying to take the action. The third is, of course, the action. And it could be a HTTP method like get, put, post. The fourth piece of information is the resource that the principal is trying to access. Fifth piece of information is any optional context that you want to pass. In my case, I want to pass the referral period as the context. And the last piece of information here is the data set that relates the resource, attributes, and principal. The next step in my Lambda code is to actually call isAuthorize API on verified permission. And the last step is to, based on the response from verified principal, I'm enforcing the decision, returning allow or deny to API Gateway. Now, this is a sample Python code, not at all difficult. Like any AWS service, you use SDK to create a client and execute an API against that client. But there are few important considerations. From performance perspective, you may have a requirement to execute several authorization calls simultaneously. As an example, you may want to query all the resources that a certain principal has access to, or all the resources that can be accessed by a certain principal. You can execute that using batch authorization call that verified permission supports and cache them. And that avoids subsequent multiple calls to verified permission, thus helping you improve performance. And if you are in regulated industry or an enterprise customer, auditability is key aspect of any application. So verified permission streams audit data to CloudTrail. External auditors can review the policies for correctness and completeness. And of course, you can set alarms for and notifications for any anomalies. Now, I'll invite Con to share their journey using verified permission to simplify permissions.
Thank you, Kunal. So hi, everyone. I'm the Chief Technology Officer of Grosvenor Engineering Group, Con Salikis. So I'll just start with a bit of background. So we started our journey at Grosvenor since 1996, looking after technical assets in buildings and currently looking after some of the largest property portfolios in Australia and New Zealand. So for us, we believe that in proactive and data-driven maintenance when it comes to HVAC and fire systems, so our philosophy is to fix the roof before it rains to deliver greener and sustainable buildings along their outcomes. So for us to be able to achieve that, we realized early in our journey that we needed to build our own ERP and CMMS system that we call ARMS. So ARMS effectively is an asset information system that allows us to provide prescriptive maintenance to our customers. We reach out all the way to our technicians in the field and aggregate information from IoT and building management systems. So to this day, ARMS has looked after more than 47,000 buildings, resolving more than 17 million asset issues across 1.6 million assets. So because of its broad involvement, ARMS has accumulated different personas over the years that has led to a complicated data model. Each user requires distinct permissions that might be linked to different entities. For example, a technician might be requiring access to a specific building or even a specific technical asset. So looking at our challenges, as we recently began to modernize our application, we quickly faced the challenge of authorization. We had to pivot from an old role-based access controls approach to a new attribute-based access controls approach. So with a rebuild, we boiled down our decisions on 3 key challenges and started evaluating. The first challenge was to avoid building a customized solution because we wanted to avoid hitting roadblocks in our future roadmap. We also wanted to reduce our security risks with maintaining a custom system. The second challenge was about flexibility. As our features would evolve in our products and add new personas, we wanted to avoid retooling our solutions in the future. And we wanted to also use different data stores with a separate policy repository that can talk to our traditional RDBMSs or graph databases. The third challenge was about scale. We wanted to allow our solutions to grow without having the administrative overheads that come with achieving those scales. So we're at that point where we're evaluating different solutions, primarily open source, and we couldn't quite find the right fit to fit our challenges. So it was at that point that AVP was announced reaching its general availability. We put a proof of concept together and tested different policies in the policy playground, trying to match our business requirements. So the result was relying on CEDA's syntax to drive that business logic. We achieved high performance, provided that we followed the guidelines of atomic schemas, and had smaller switching costs because of the consumption-based models that come with AVP. So now I just wanted to show you a few use cases that helped us modernize an application using AVP. In the first one, similar to what Kunal just showed you earlier, the application makes a login request to the front end using Cognito. On the second step here, you can see that Cognito validates the request using invoking a Lambda function with a pre-authorization trigger and injects custom attributes from our database into the tokens. So when a JWT is generating from Cognito in the callback request, it then forwards it and is exchanged as a bearer token with the API gateway that is then validated and decoded as with the custom attributes that are then passed in step 6 to the policy store. So if the policy store finds those custom attributes, it will provide an allowed decision as a response, and it will simply allow the Lambda service to process the request. Now, on the second use case, I wanted to show you an approach that we took to creatively utilize verified permissions to drive UI behavior. Because different users might require different permissions, it was important for us to have a flexible user interface that can change with each user. So here, different to the similar example, similar to the previous example, the steps 1, 2, and 3 use bearer tokens to validate the request, but the custom authorizer only validates the token. It doesn't invoke the verified permission service. Instead, on step 5, we have a dedicated routes that basically retrieve and look for policies for that specific user and find through AVP UI-specific policies that can be matched then as a list and forwarded back to the front end to change the UI behavior. So just to recap on those two use cases, those two examples are using policies from CEDA that are atomic and flexible that can match each use case. The UI policies are driven either by user groups or individual users that are stored in Cognito. The policies are set to deny by default and are stored in the front end as a result to limit those API calls with TTL expiries. When it comes to validating API calls, we started with a simple RBAC approach, but quickly pivoted to ABAC without changing our architecture. So effectively, we relied on the semantic nature of CEDA to drive that change without changing anything in our front end or back end. Now, on the third use case, I just wanted to share with you an interesting challenge that we faced when we integrated our energy management software that we call GEMS. So with GEMS, we wanted to understand more of the context that allows a permit decision because we use said data lakes to collect that information back and send it back to the API gateway. So the difference here compared to the other use cases is that when an allow decision is sent from the Lambda authorizer back to the Lambda service, we basically provide context to the scope of the permission that was permitted to forward then back to the Lambda service. So the Lambda service here in step 3 constructs a query that is relevant to the scope and limits the information from the data lake to provide the response back to the API gateway. So looking at lessons learned, the first one is quite simple. Don't invent a CEDA, just go with a pre-built solution. The second lesson is that while CEDA comes with a steep learning curve, it brings with it the flexibility and scale that can pay off in the long run. The third lesson for us was that AVP can be more than just permissions. As I showed you in the last two use cases, you can come up with other sophisticated ways to use policies and the service to construct and enhance your application's behavior. For Grosvenor, the next steps are in the short run to enhance our batch authorized approach in our front end and how we store those policies, and to create a new feature that utilizes AVP audit trail to show policy changes to our end user. In the long run, we're building an open and public service that allows machine-to-machine communication with IoT systems and other integrations, utilizing AVP for its permission service. That's it for me.
Thank you, Con. Thanks for sharing all the learnings and the use cases. All right, some of the key takeaways. The Lambda code that you saw earlier, in that Lambda code, I had few user types, few actions. The code doesn't change much. If you have 200 users, 500 action types, doesn't change much. That's making the code very scalable. And by offloading the permissions to verified permission, you can make changes to those authorization policies independent of your code deployment. You do not need to deploy code if you have any authorization rule changes because of your regulation or application requirements. And of course, you get all the benefits of managed service, and you focus on your authorization rules, not on operational heavy lifting. And if there is one thing that I want you to take away from this session, it'll be avoid building custom authorization applications. They are hard to build, difficult to scale and audit, and complex to maintain. And if you find yourself over here, we've got you covered. Verified Permission has recently launched a quick start wizard. Zero code, you can easily integrate your user information using the wizard with Cognito. You can pull your API information, all the endpoints and actions automatically. You define the relationship between users and groups, and that wizard helps you to write the schemas. It creates schemas and policies automatically. It also creates the Lambda authorizer that you saw earlier. You integrate that Lambda authorizer with your API, and there you go. Makes it really easy to get started. And time to get your cameras ready. As I promised earlier, here are some of the good resources to get you started. I've got few good blog posts and easy to follow workshop. And of course, if you're looking to kickstart your learnings, make sure to visit AWS Skill Builder. Hope you've enjoyed this session, and please do not forget to leave feedback for us. That helps us grow. And if you haven't downloaded the app, these are the QR codes to download the app and a QR code to submit feedback for this session. Thank you.